a minute. Right. Oh, now don't be deceived. This is not as big as it looks yet because the drive shaft is very long, so I have to use some of my other canopies to basically mount it on. It's not this long yet. This is where I'm up to right here, right? The rest of these are my old canopies, you know, from, well, my other stuff. The drive shaft sticks out. Now, when I use the acetone on my turbines, I have to let the air dry slowly inside, otherwise they warp. You know, if you, basically when I make my wind turbines, I've got to clamp them between two old hard drive platters, and I'm using this steel washer on the back of a hard drive platter, which is attached to a bearing, and the bearing is flat against the back of the washer, and there's a piece of drive shaft sticking through. That's to make sure I've got the centre hole directly centred. Alright, I just wanted to cover that. Now, my assembly only goes up to here, right? I'll show you what I mean. Oh, can't get it out. No, it's actually here. Ah, come out. Right, here we go. The reason I've got it stuck in there is because the drive shaft's sticking out, and I want to keep it that way up because of the weight of the fans while it's evening out, and I've got tape to seal it as well. This is how far we are at the moment, right? This is where we are at the moment. This is just empty stuff, you know, there's nothing in there. Right, so I'll stick it the other way up for a minute. I just wanted to show you some stuff. Right, so there's my turbines, and actually you have to look down deep down there to see them, because I've got an air brake in between. This thing that's not moving is the air brake. Right, so air brake's going between each section. Right, there's my turbine down there. It looks pretty cool when I turn it, actually. Right, so let's put it on its side. Now, where we are at the moment, because it's a slow process printing all this stuff, it takes about 5 hours to print just one of these, and that one's 5 hours, and that one's 5 hours, and that one's 5 hours. I can't do it all in one day, but this is my ruler, right? And we're about, I've got my ruler upside down. I use inches anyway. At the moment, if I stick that ruler down there, it's near enough. We're about, oh god, I can't see. Where's the light? Hang on, it's got them in the shadow. We're at 9 inches at the moment. Yeah, we're about 9 inches. So anyway, it's going to be about a foot. So when I've occupied all of this drive shaft, then I'll have the option. You see, then when this drive shaft's all used up, then I'll be able to couple this air intake, the air intake, to my centrifugal fan array, which is pushing air out to drive all this. The reason I can't do it at the moment is because I still have to print the canopies, and I don't want to be using those canopies really, because they've only got a small hole in the middle. I want to use that kind of arrangement, you know, so that the air can flow freely. So now, when this is done, this assembly, I can extend it, because the drive shafts are only getting 12 inches long, and in order to extend it, it would be complicated to have this a gear system inside the canopy. It would be very awkward to do. So I thought, well, I went on the internet today and I was looking for a universal joint. Anyway, now it's an interesting story what happened today, because I was actually attacked by a virus. I downloaded this universal joint zip file of Thingiverse, and now the file was just terrible. I'm not going to mention any names, but just be careful when you're downloading zip files, because some WinRAR zip files can have script coding in them, and I suspect that's what it was, because I was attacked by this nasty virus, and my computer screen, I've got a snooker on right now, my computer screen was completely filled with little red-faced devils with horns. My computer was frozen. I had to reset the computer, and I had to restore my C drive because I've got four physical hard drives actually, and I've got about 5 partition drives on one of those physical drives. So all my data is basically scattered across other partitions. So I didn't lose any data. I had to restore my entire C drive from a backup using a disk rescue system. You know, restored the image. I'm not going to mention any names because I'm not going to do free advertising for them. But well, Macrium Reflect is one, and it's open source, so you could use that. Anyway, so I restored my entire C drive within 20 minutes, and the nasty virus with the red devil faces was gone. Thank God for that. It was kind of worrying actually. So yes, it did give me a bit of a rattle. It rattled me a little bit because I thought my hard drive had packed up on me at first. So anyway, long story short, I restored my computer. Everything's working okay again. We're still on track with the process, and I did find another universal joint on Thingiverse, and this is what I 3D printed. I scaled it down because the actual hole was 30mm originally, and I had to adjust it because the idea is that if I want to make these turbines which will turn a generator. Now here's this is a hydroelectric generator which I've actually converted. Let's see if I can get it to focus. Come on, focus. Alright, so there's my hydroelectric generator I got off from China. And it has basically a great big massive fan on it. Now I wanted to take that fan off, but I couldn't because the magnets are embedded inside it. So what I did was I 3D printed this pink thing, which basically replaced the original housing for the water jets because it was using that. I'll just get that one actually and show you what I mean. Where is it? Somewhere around here. Here it is. Now this is the original thing that had the water pipes on it, so the water would come in through this hole down here and it would turn this turbine. So because I couldn't remove the turbine because the magnets were embedded in it, I 3D printed oh, what do you call it? Oh, I don't know if I've got another one lying around here. I think I've 3D printed 2 of them. I can't think where it is. Is it over here? Nope. I must have tossed it. Because that one, it fell apart on me. I didn't do it right. So what I did was I 3D printed this thing like fingers that would... basically the fingers would go through the blades of the fan. And I put a cap on the end. And I stuck my pulley on to that. So when I pull this out, you can see it pops in because the magnets. Right. So I stuck 2 pulleys on there and a large pulley on the end, so I can use that to attach a drive belt. And the drive belt will turn this hydroelectric generator. Will be driven by these turbines, which will be driven by the centrifugal force of the fans. I've got 2 motors mounted on there right now. So the idea is to use that air pressure through this system to turn this generator. Now if I want to extend this system, then I can use my universal joint. And the universal joint, I've made it exactly right size. And it's using some just nails basically. In the actual original design they were using screws, and I thought, well, bugger that, I'm not going to mess about trying to find some small screws. I used some small nails, and I've ABS plastic bonded them in there so they can't fall out. Then I used some plastic gear grease on the, which I got from China, which you can't read because it's in Chinese. I wrote that on it because I couldn't read it what it was. You might think it's hand cream, so I wanted to make sure I didn't mistake it for that, and my daughter would use it or something. So I made this this universal joint, and it works. Well, you can see it's going to work. So I can couple the drive shaft, and I will no longer have offset problems, because I'll be able to attach it on one end of my drive shaft and attach it to another one, and I could have more than one of these in series with another one, and they'll be coupled in such a way that this pipe here hooks onto the next one, and so on, and the universal joint will be in between them like that, reset inside the canopy. So anyway, that's what that is for, but it's not to couple this to that, because that is generating the air pressure which I'm going to use to drive these turbines, which is an experiment in power conversion. Anyway, that's the idea. It's an experiment in power conversion using air pressure and to drive additional turbines. Because I've got this idea about windmills, right? Think about it like a windmill. Now, normally a windmill is in the middle of the countryside, standing on its own, and the wind comes along, turns the windmill, and once it's done that, it's past the windmill and it's no longer turning that windmill. It's just gone, right? Now, what would happen if you had a wind tunnel, and in that wind tunnel you had about half a dozen or maybe 24 turbines, and you had that tunnel was so long that the air pressure from one end to the other end was so great that it could turn all of those turbines? That would be more efficient than just having one windmill scattered you know, all over the countryside. I mean, you could put them all in one big tube in a long line and use, I mean, think about a chimney. When you've got a long chimney that goes way, way up, you know, 200 feet tall, you get a massive amount of air suction at the bottom, which is called the updraft. And that, you could use that updraft to turn multiple turbines on the way up. Obviously, there's going to be losses because of pressure and everything else, but it should be able to turn more than one at least. Use it over and over again. That's the idea. So basically what I've got here is a whole series of turbines, and as the air moves along it will add to torque. So we're not actually gaining, we won't gain much RPM because all of the turbines are connected to the same drive shaft, but as the air moves through it will hit the stator will stop the air from spinning and make it static, so it's in a straight line, so it can turn the next turbine which is spinning. The air will be in vortex spinning, it will hit the next stator which will stall it, but it will still keep moving along the tube, and then it will turn the next turbine and so on. And each time it's doing that, it's adding torque to the drive shaft. So that is the idea, is to add torque, you know, to the drive shaft, which are all connected together. So we might not gain much speed, but we should overcome some of the losses, because most of the losses are due to the fact that air is very thin, and we have wind resistance obviously, but if we're using a high vacuum type arrangement, we have pressure to our advantage, because the vacuum cleaner, for example, when you block the air, it will speed up, so it's doing less work when you actually put a load on it. That is the idea. So that is why I'm experimenting with this. What else is there? Sorry, I'm not showing you much at the moment. I'm just really talking a lot. So anyway, that's where we are at the moment. I'm still printing another canopy, which is going to be probably another 2 hours, because it says 83%, so it's probably going to be another 2 hours for that. But I'm going to be going to bed soon. So anyway, it's taken a lot of time, but these canopies I did for this thing, so I could add more to that. So these aren't wasted, these are just redundant right now. I'd have to print more turbines for that thing, but I stopped for a while, because the more turbines I add to that, the generator that generates the air pressure, the centrifugal force that generates the air pressure, the more motor torque I need to drive it. Which is why I'm thinking in reverse, that by using that air pressure and multiply it, I should get more torque at this end, instead of putting more drag on this end, which is generating the air flow. I want to use that torque and increase it on this end, on the output side, which is basically like loads of little windmills all in a long line down the tube, basically. So that's explaining it in simplified version. I could take it apart, but I don't want to do, because I've had to have a right farting about today, what with the virus and trying to get this thing lined up so it wasn't rubbing on anything. It was, yeah, it was just a nightmare, because my drive shaft kept slipping, and I had to actually super glue the drive shaft onto the end of one of the bearings so it wouldn't, and it turns really easy actually. I had to basically super glue one end so it didn't keep getting stuck. I've got the little blue dot in there. In fact, don't see it. Where's the blue dot? There it is. So when it's spinning, you can actually see the blue dot going past. This back thing is a stator. Doesn't matter. It looks ugly, but it doesn't matter because it's an air brake. But this one failed to print. Actually, I just stuck it on the back too for now. But anyway, this is where we're at, and more printing to do. And this thing's getting quite heavy actually. So that's another factor to weigh in, is the amount of weight on the bearings. The more weight on the bearings, the more friction we're going to have, which is a loss. But I'm hoping that each fan that's in there will overcome that particular loss of its own weight. So, well, we'll find out, won't we? That's the whole point of experimenting and trying things. But it's safe, it's just air. I'm not experimenting with any chemicals, I'm not experimenting with anything dangerous, it's just air. So turbines are environmentally friendly, even when they're indoors. Anyway, thanks for that, for watching. I don't know what else I can add really. Yeah, I think that's it for now. Bye for now.